Hi everybody. Today we are going to be talking about operations with functions. So our objectives for today are that students will be able to evaluate polynomial functions. Let's get started. When we're talking about operations with functions, we're saying that you can add, subtract, multiply, and divide functions. So for example, if you're given f of x equals 3x minus 7 and g of x equals 13 minus 2x, and we want to find what f of x plus g of x is, all we need to do is take whatever f of x equals, so 3x minus 7, we're adding it together with what g of x equals, 13 minus 2x. And you can put these in parentheses so that you know you're substituting those values in. So we substituted 3x minus 7 in for f of x. We substituted 13 minus 2x in for g of x. Now we're adding these functions together. And then all we do now is it's simply just algebra and we combine like terms. So combine the x's together, 3x minus 2x gives us x. Negative 7 plus 13 is going to give us positive 6. So our final answer is just x plus 6. Therefore, instead of writing this function as f of x plus g of x, this new function can be denoted as, we can say, f plus g of x. And just a quick reminder, anytime we're talking about functions and we have an f parenthesis, x parenthesis, we pronounce this as f of x. This is g of x. So we would read this as f plus g of x, and this is our new function. All right, so now let's talk about all of the operations. So in the example we just did, we were dealing with the sum. So when we said f plus g of x, what we were saying was f of x plus g of x. So this is what you will see, and this is how you will solve it. You're going to rewrite it as f of x plus g of x, and then substitute f of x in here, and then substitute whatever g of x equals in for here. When we're talking about the difference, you're going to see it looking like this. So f minus g of x, and how you're going to rewrite this is f of x minus g of x. So we would substitute in f of x here, and then subtract it from g of x. And make sure you're using parentheses because when we're dealing with the difference, you have to be sure to distribute the subtraction sign to everything inside of the g of x term. All right, now when we're dealing with, hold on, let me get rid of that little mark. All right, now when we're dealing with the product, this is f times g of x. So how you're going to rewrite this is, you guessed it, f of x times g of x. And then last but not least, when we're dealing with the quotient, what we're saying is f divided by g of x. So we would rewrite this as f of x over g of x. And when we're talking about the quotient, it has this little asterisk here because the important thing we need to remember when we're dealing with the quotient of functions is that in the denominator cannot equal 0. So if the denominator ever equals 0, our domain, this affects our domain. So if denominator, that's a tough one to spell, equals 0, this affects our domain. So we can't have, so whatever values make the denominator equal to 0, this changes what our domain would be. So we're going to do a few examples where this is true. So anytime we're dealing with the sum, difference, and product, our domain is all real numbers. But when we're dealing with quotient, the quotient or the denominator cannot be 0. So let's go through a few examples and see how this works. All right, number 1, we're given that f of x equals x squared minus 8x plus 4. We're given that g of x equals 4x minus 3. And we're given that h of x equals x plus 2. And we want to find each function. We also want to indicate any restrictions on the domain. So the restrictions on the domain occur when we're dealing with quotient. So for number 1, we're dealing with f plus g of x. So we're dealing with sum. So we want to rewrite this as f of x plus g of x, because that's what we're talking about here. Then we want to substitute in x squared minus 8x plus 4 for f of x. And then it's plus, because we're dealing with sum. Substitute 4x minus 3 in for g of x. Then we're simply just combining like terms because we're dealing with sum here. We're just adding. So first like term, always in standard form, we want to put it at the highest degree first. So we've got a single x squared. That's going to go first. Then we've got negative 8x plus 4x. So minus 4x. Last but not least, positive 4 minus 3 is going to give us plus 1. And there's our solution. All right, an important thing to remember here is that we're not dealing with quotients, so there are no restrictions on the domain. And how we would write this is that the domain is all real numbers. So x can equal any number from negative infinity to positive infinity. There's no restrictions on the domain, so domain is all real numbers. And this has to be included in your final answer. All right, number 2, we're dealing with the difference. And the reason we're not just doing the odds is because numbers 1, 2, 3, and 4 cover each of the 4, sum, difference, product, and quotient. So we're going to do one of each of them. So number 2, it's f minus h of x. So we want to rewrite this as f of x minus h of x. And then we want to substitute in the values for what f of x equals and what h of x equals. So we know f of x equals x squared minus 8x plus 4, and then we're subtracting h of x, or x plus 2. Now the important thing to remember when we're dealing with difference is that we have to distribute this negative sign to both terms inside the second parenthesis. So we would rewrite this as minus x minus 2. And then we want to rewrite the first parenthesis, the first function, and we can drop the parentheses. All right, now it's just combining like terms. We only have one x squared, so that goes first. Then we've got negative 8x minus x gives us minus 9x. Positive 4 minus 2 gives us plus 2. And there's our solution. All right, let's move on to number 3. All right, an important thing to remember here is that we're not dealing with the quotient rule, therefore there's no restrictions on the domain, so we have to say that domain is all real numbers, and that's part of our final answer. All right, number 3, we're dealing with h times g of x, so we want to rewrite this as h of x times g of x. Then the next thing we want to do is substitute in what h of x equals and what g of x equals. So we know h of x equals x plus 2. Substitute that in for h of x. Times g of x equals 4x minus 3. All right, Now we know that because this is multiplication, we don't even need this symbol here. It's just two parentheses next to each other. They're both binomials, so what we want to do is FOIL. So start with the first. X times 4x gives us 4x squared. The outside, x times negative 3 gives us negative 3x. Inside, positive 8x. And then the last terms, minus 6. All right, then we're just going to combine like terms. Negative 3x plus 8x, that's going to give us 5x. Bring down the negative 6 and the 4x squared. And that's our final answer. All right, also we have to remember that there's no restrictions on the domain here. So we would say that the domain is all real numbers. And that would be part of our final answer. All right, last but not least, we're dealing with quotient. So we have f divided by h of x. We want to rewrite this as f of x divided by h of x. All right, and then we're going to substitute in those values. So we know f of x equals x squared minus 8x plus 4 over x plus 2. All right, now this is our final answer. However, because we're dealing with quotient, we have to look at this denominator, we have to see what's in the denominator, and we have to ask ourselves, what would make this denominator 0? So, because if the denominator is 0, we know that we can't do it. This is how we have restrictions in the domain. Domain deals with x, so we have to ask ourselves, what can't x equal? So because we can't have the denominator equaling 0. So how you do this is you set the denominator equal to 0. So what value of x would make the denominator 0? Subtract 2, and we get that if x is negative 2, then our denominator is 0, and we can't do this. So the restrictions on our domain, we would say that the domain x cannot equal negative 2. And that would be our final answer. All right. For all the previous problems, our domain was all real numbers. There were no restrictions on the domain, so we didn't have to worry about it. But for this one, we have to be sure to say, what would make the denominator 0? All right, x cannot equal that number. All right, we're going to skip over to number 7 because it's slightly different. Numbers 5 and 6 are very similar to 1 through 4, which we just went over. So number 7 is different because instead of saying f plus g of x, we're saying f plus g of negative 2. So we want to rewrite this slightly different. So instead of saying f of x plus g of x, we want to say f of negative 2 plus g of negative 2. And then anytime we see an x, what we're going to do is plug in negative 2 into each equation or each expression. So the first thing you want to do is start by substituting in f of x. And anytime you see an x, substitute in a negative 2. So we have 2 times negative 2 squared. Because instead of the 2x squared, we're going to plug in negative 2 for x. Minus, instead of plugging in x, we're going to plug in negative 2. Minus 12. Then, plus g of negative 2. So g is x. So instead of writing an x, we're going to write in negative 2 plus 7. All right, and just a quick note, these brackets right here are what we use in math when we know we're going to have parentheses. Instead of doing parentheses, double parentheses, we use a bracket on the outside, parentheses on the inside. It's the same thing as parentheses. All right, so now we want to simplify. Order of operations, we want to do exponent. We want to do what's inside the parentheses first, exponents within the parentheses first. So we would say that this is hold on, let me get my pen. We would say this is 2 times 4 minus the negative becomes plus 2 minus 12 plus negative 2 plus 7 gives us 5. All right, then this becomes 8 plus 2 minus 12 plus 5. 8 plus 2 is 10, minus 2 gives us, or minus 12 gives us negative 2 plus 5, and our final answer is 3. So instead of getting an expression or an equation as an expression as our final answer, we get a whole number. Our final answer is 3. All right, so that's where these slightly differ from the previous problems. All right, for number 9, what I want you to do is pause the video, attempt to do it on your own. So we've got f times g of negative 1. So you're going to use the product of f of negative 1 times g of negative 1. And I want you to try to do this on your own. When you unpause the video, the answer will be written on here so you can check your work. So go ahead and pause the video now and get started. All right, so you should have done f of negative 1 times g of negative 1. Copy down the expression for f of x, what f of x equals. But anytime you see an x, plug in a negative 1 using parentheses. Copy down what g of x equals, but anytime you see an x, plug in a negative 1. And there you go. Then we want to do what's inside the parentheses first. Exponents within the parentheses first, so negative 1 times negative 1 gives you positive 1. Then 2 times 1 gives you 2. Make sure that you have minus a negative, so this becomes positive plus 1. Combine like terms. 3 minus 12 gives you negative 9. Now on the right side of our equation, we'd have negative 1 plus 7 gives you positive 6. And then we're just going to bring that down all the way. Negative 9 times positive 6, your final answer is negative 54. All right, the last thing we're going to learn today is called compositions of functions. So another method to combine functions is called a composition. So if you're given f of x and g of x, the composition function f of g of x, so this little open circle means of as well, is defined as, so this is how we would write it. We would say that f of g of x equals f of g of x. It's just two different ways to write it. It's read exactly the same. All right, let's do a few examples on how exactly do we do this. All right, so now our directions. We're dealing with composition of functions. We're given f of x, g of x, h of x, and we want to find what the composition of this function is. So first off, we're given f of g of x. We want to rewrite this as f of g of x. Then what we want to do is substitute in g of x. So what is g of x? X minus 1. We want to substitute that in for g of x. Our goal is to work from the inside out. So start with what's on the inside and work your way out. So we've got f of, substitute in g of x, f of x minus 1. Now we want to deal with what does f of x equal? So f of x equals x to the third plus 8. So we're saying f of x minus 1 equals x to the third plus 8. So anytime you see an x, we want to substitute in x minus 1. So f of x minus 1 equals x minus 1 to the third plus 8. Then it's just algebra. Now what we're doing is we have to multiply this out. And because there's a negative sign, it's subtraction. We're dealing with the difference of x and 1. We have to FOIL it out. So we want to say x minus 1 times x minus 1 times x minus 1 plus 8. So start with the first two terms. First, outer, inner, last, Copy the rest of the equation. Combine like terms. Copy the rest of the equation. All right, now let's move this forward so we have enough room. All right, then we want to multiply this times every term, x times every term in the first trinomial. So we get x to the third minus 2x squared plus x, then -1 times every term. So we get negative x squared plus 2x minus 1. Then combine like terms, x to the third minus 3x squared plus 3x minus 1. And then don't forget to bring down that plus 8. So combining the like terms, the two constants, our final answer is x to the third minus 3x squared plus 3x plus 7. And there is the composition of our function. All right, with number 13, we just want to practice writing it out. How do we solve this? What does it look like? So f of h of x looks like this. We say f of h of x. So we're taking the composition, we're taking the h of x and putting it inside our function. That's what the open circle means. Okay, now we want to work from the inside out, so we want to substitute h of x inside the parentheses, substitute it in. So we end up with f of 5 minus x minus 3, or 5 times x minus 3. All right, now we want to ask ourselves, what does f of x look like? F of x is equal to x to the third plus 8. So anytime we see an x, we want to substitute in 5x minus 3. So we would rewrite this as f of 5x minus 3 equals, we see an x, we're going to substitute in 5x minus 3 to the third plus 8. All right, now to save us some time, I'm not going to have you do this problem because you would have to FOIL. All right, oops, I want my pen. All right, you would have to FOIL this out. 5x minus 3 times 5x minus 3 times 5x minus 3, then add the 8. All right, we just did a problem like this previously. If you want to do this and you want to check your answer, just raise your hand and I'll come on by and check your answer for you. All right, but the important thing that I wanted you to practice with this problem is getting to this point right here, where you have your expression and you just have to FOIL it out and simplify. All right, now let's move on to the last problem, problem number 15. All right, last but not least, we're dealing with composition of functions, but we're given a value for x. Instead of saying g of h of x, we're saying g of h of 2. So we want to start by rewriting this composition just like we would if this were an x. So we would want to say g of h of, oops, not x, of 2. All right, instead of writing an x, we write a 2. Then we still want to work from the inside out, so we want to substitute in h of x in here. But instead of writing an x, anytime we see an x, we're going to put a 2. So this becomes, all right, g of 5, not x, we want to write a 2, minus 3. Then we can simplify what's inside the parentheses. We get 10 minus 3, and we end up with g of 7. All right, now it's the same idea. We're dealing with g of 7, so we look at our g of x equation, and we know g of 7 is going to equal x minus 1, but instead of writing an x, we want to write a 7, so 7 minus 1. So g of 7 equals, not 7 minus 1, equals 6. 7 minus 1 is 6. All right, so our final answer is 6. All right, the important thing to remember when you're dealing with composition of functions is always work from the inside out. If you can rewrite it correctly, then work from the inside out. Anytime you see an x, substitute this value in. Anytime you see an x here, substitute this value in. And you're going to get a final answer as a whole number, not an expression with variables. When you're given an x here, your final answer is just going to be a simplified expression. When you're given a number, your final answer is going to be a number. All right, so I hope you learned a little bit about operations with functions today. Look to your teacher or look to the board to see what to do next, and I hope you have a great day.